Hey there everybody, this is Mr. Deacon here, and in this video we're going to carry on our little recap of some pre-calc and Algebra 2 topics dealing with domain. So today we're going to focus much more on doing things algebraically. These three warm-up problems, we actually did these in the previous video, so if you want to see these, go ahead and watch the 1.2 or the day 2 video. Let's take a look now at these graphs. We want to establish domain and range. So domain, again, is going to be our x values. As I read this left to right, where's my function defined, or where is it undefined? Well, I'm looking at this graph, and it looks like we've got two vertical asymptotes. Even though they're not graphed here, it looks like there's a clear split in the function where I have a discontinuity. I transport from one part of the graph to the other. Well, that's going to be a break in the domain. So as I'm walking along the x-axis, I have a y value for every x value here until I get specifically at -2. So -2, it's undefined. There's an asymptote here. But just past -2 at -1.9999, we do have a y value. So it picks up where it left off. That being said, our domain can be written as the following: -infinity all the way up to -2. This is going to be a parenthesis, not a bracket, because we're not actually hitting -2. We're just approaching it. And then we have -2 to +2, and that is this little section right here. And then we have 2 to infinity. Now, when you see these things written out, these are three separate intervals. It's not uncommon to see a union symbol in between them. So this union symbol is just a mathematical way to say and. So if you see that, just don't be surprised. All right, next one. Here I've got, it looks like a hyperbola that's going left and right, and only one half of it, so I only have the top half. As I'm going left to right with the domain here, my x values are defined. Right, I've got -5, 4.5, -4, 3.5, all the way up until -2. And then in between -2, there's nothing. And then I carry on this way. Since there's no asymptote and we actually have a closed point here, we are going to have an inclusive value. So we're going to go from -infinity to -2, close bracket, because that point is included. And then also from +2 to infinity. When we're writing these, again, it's always important to go left to right. So if you ever have a -infinity, that should always be on the left-hand side of your interval, never the right. Conversely, for +infinity, it is always on the right-hand side. All right, so now let's get some more practice dealing with algebraic domains. So we discussed this in the previous video. Again, if you want to check back there. The two most common scenarios we're going to see is if you see an x variable in the denominator of a function, or if you see the x variable underneath a radical, and that radical would have an even number root, so a 4th root, 6th root, square root, what have you. All right, here we go. Let's take a look if we have a variable in the denominator. If you have a variable in the denominator, you cannot have it equal to 0. So that denominator cannot equal 0. X minus 2 is not allowed to equal 0. So that means x is not allowed to equal 2. X can be anything except for 2. So to write that as a domain, I've got -infinity to +2, and then +2 to infinity. Some people might find this helpful to write out a number line and just block off the values that are not included. So if that helps you, go for it. If it doesn't help you, don't do it. All right, next one. 3 plus x. I'm looking at that denominator. X is not allowed to equal -3. So I'd write my domain, -infinity all the way up to -3, and then -3 to +infinity. Now let's check square roots. Anytime you have an even number radical, so here I've got a 4th root, here I've got a square root, you cannot have a negative value underneath that radical. So whatever is underneath that radical the radicand, has to be 0 or bigger. So x minus 2 has to be greater than or equal to 0. Therefore, x has to be greater than or equal to 2. So if it helps you to visualize a number line, we're taking all values from 2 and bigger. So we would write that as 2, comma, infinity. Next one here, similar process. 3 plus x has to be greater than or equal to 0. Therefore, x is greater than or equal to negative 3. Same exact situation with our number line here. The only difference is now it's a negative 3 instead of a 2. So we're going from negative 3 to positive infinity. All right, so now let's get some mixed practice. We've got 6 problems here that we'll zip through, and then we'll call it a day there. I think these 6 problems will be good. We'll cover these other ones in class, but for now we'll just focus on these 6. All right, number 1, we just want the domain here. I'm not seeing any variable, any x in the denominator. I'm not seeing any radical. There's no funky business here. This is just a straight up all real numbers. Domain, negative to positive infinity. Number 2, I'm looking in that denominator. I see an x down there. It is not allowed to equal 0. I need to figure out which x values would make that thing equal 0. So I'm going to factor this. Let's see, numbers that would multiply to be a negative 6 but add up to a negative 1, that would be a negative 3 and a positive 2. If I solve this out using the zero product property, I find that x is not allowed to equal 3 and x is not allowed to equal negative 2. Every other x value is fair game except for those 2. So negative 2 is off limits. 3 is off limits. Everything else, we're good to go. So to write this as a domain, we'd have negative infinity all the way to negative 2. Everything between negative 2 and positive 3. And everything from 3 to positive infinity. All right, number 3, we have a square root. That means our radicand has to be greater than or equal to 0. So radicand has to be greater than or equal to 0. Now I'm noticing here, this isn't just a plain old x scenario. This is an x squared. And we have to be really careful anytime there's an x squared. We have to do what's called a sign analysis. So what we're going to do is write this thing in factored form. We're going to pretend it's kind of the same thing as what we just saw in number 2. And we're going to then perform a sign analysis. So I'm going to factor this out. 36 minus x squared is a difference of squares pattern that breaks into 6 minus x and 6 plus x. Those are conjugate pairs. So that has to be greater than or equal to 0. Now I'm noticing that exactly at 6 and negative 6, that's when my function is going to equal 0. And that's okay. We're allowed to equal 0. It just can't be negative. I need to figure out what's going on for values in between here, what's going on for values back here. So that's where we do a sign analysis. How a sign analysis works is we're going to just choose some arbitrary number back here. I'm going to say negative 10. And I'm going to plug that in. So 6 minus negative 10 times 6 plus 10. Well, minus a negative turns into a plus. I don't need to know exactly what this number is. I just need to know that this is a positive times a positive. Oops, no, I screwed up. This would have been a 6 plus a negative 10. Let's go ahead and fix that. So that's a 6 minus 10. Which means I'd have a positive number times a negative number. So that is a negative result, which means that part of the graph is going to be off limits. Then we'll choose some number in the middle here. Let's say I choose 0. If I plug in 0, 6 minus 0 times 6 plus 0, well, that is a positive times a positive that is a positive result, so that's good. Then I'll choose some number bigger than 6 over here. I'll choose positive 10. We have 6 minus 10 and 6 plus 10. So 6 minus 10, 6 plus 10, that would be a negative times a positive. That overall result would be a negative number. I don't care what the specific number is, I just need to know positive versus negative. Well, it looks like anything in this range of numbers would meet the criteria of being greater than or equal to 0. Greater than 0 meaning positive, equal to 0 meaning exactly 0. So we write that out as negative 6 to positive 6, close parentheses. All right, that was a doozy. Next one here. I've got x in the denominator, but it's also underneath a radical. So that means x minus 4 has to be greater than or equal to 0. But also, x minus 4 is not allowed to equal 0. So we have this criteria because it's in a radical, but this criteria because it's in the denominator. I can combine both of these into the single expression, x minus 4 is strictly greater than 0. So 0 is going to be off limits on this one because x is in the bottom. So when we solve that out, x is greater than, hey, that's not what I wanted. X is greater than 4. So as an interval, you'd get 4 to positive infinity. Now the 4 here gets a parenthesis because that was strictly greater than, not a greater than or equal to. All right, number 5 is going to look very similar to number 3. Number 5, I've got x squared minus x minus 20. That has to be greater than or equal to 0. Let's factor this first. Numbers that multiply to be a negative 20, but add up to a negative 1, we're going to get negative 5 and positive 4. Then we have to do a sign analysis. We're going to visualize a number line. I know that exactly at negative 4 and positive 5, our function is equaling 0. But I need to know what happens way back here. If I plugged in some negative number, say negative 10, negative 10 minus 5 is a negative result. Negative 10 plus 4 is a negative result. That is a positive product. I don't care what the specific product is, I just care that it's positive. Between negative 4 and 5, let's say 0. If I plug in 0, 0 minus 5 is negative. 0 plus 4, that's positive. A negative number times a positive number is a negative result. Then let's choose something over here. Something bigger than 5. Let's go positive 10. 10 minus 5. 10 minus 5 is positive. Then here, 10 plus 4. 10 plus 4 is also positive. Positive times positive is a positive result. So my domain is going to be negative 4 and then everything back here, and then positive 5 and everything forward. To write this out in interval notation, we would have negative infinity to negative 4, and then positive 5 to positive infinity. All right, last one for this video here. We've got two separate things happening. I've got x inside of a radical, so that has to be at least 0. X plus 6 has to be greater than or equal to 0. But then I also have x in the denominator, which means it's not allowed to equal 0. So x minus 4 is not allowed to equal 0. This is going to give me two, not conflicting, but two separate domain restrictions. The first one is that my x value has to be greater than or equal to negative 6. The second one states that my x value is not allowed to equal 4. So my domain essentially is every number bigger than or equal to negative 6 except for 4. This might help to visualize a number line. So we have negative 6 and 4. That's where things get interesting. 4 is not allowed. negative 6 is. Our domain is starting at negative 6, everything bigger than it, except for 4, on to forever. So to write that as a domain, we'd have negative 6, comma, 4, parentheses because 4 is not included, and then 4 to infinity. All right, we're going to go ahead and hit the brakes there at this point for this lesson. You guys know the drill. If you have any questions, do not hesitate to reach out and ask. And as always, folks, good luck, have fun, be safe, roll tide.